That depends on a couple factors. Are the tank cars owned by the shipper or the lessor? If the tank car is owned by the shipper, then they don't have the option of placing their DOT-111 tank car fleet into a non-flammable service. It may make more economic sense to retrofit that than sell the fleet and purchase new DOT-117J tank cars. If a tank car owner has 111 tank cars and is considering to retrofit their tank cars to DOT-117R, there are several factors that should be considered. First and foremost, are you retrofitting CPC 1232 tank cars that were built at 286 gross railroad limit, or tank cars that don't meet that CPC 1232 and are only rated at 263 gross railroad limit? I believe the original intent for the FRA allowed the retrofit of existing tank cars that were CPC 1232. The non-CPC 1232 tank cars would need verification that the trucks, which are the side frames, bolsters, meet 286 gross railroad limit, wheel set changeouts from the older 6.5 by 12 bearing design to the newer 6.5 by 9 bearings, along with possible reinforcements to the subsill for the new gross railroad limit. All these are additional costs to consider on the older tank cars. In some cases, thermal protection under the existing jacket may not be required. At a previous company, we had some CPC 1232 25,500 gallon tank cars that were built with high flow pressure relief valves that didn't require thermal protection and only needed a disengaging valve handle along with some required stenciling. We retrofitted those tank cars for less than $2,000 per car. It's what I call a no-brainer. However, tank cars that do require jacket application and thermal protection along with the disengaging valve handle, costs were projected for those to be $40,000 to $50,000 per car. This was a financial decision that was based on the premise that railroads would not discriminate between freight rates on DOT-117R versus the newer DOT-117J. Remember that converted DOT-111 tank cars are not 9/16 thick, but are either 7/16 of an inch or half-inch thick, depending on whether the cars were originally jacketed or not. Furthermore, some are not equipped with thermal protection. A tank car specification class that does not allow commodity that someone intended to utilize is devastating. One could attempt to request and might obtain a hazmat special permit from PHMSA for transporting their product in a tank car that's not specified by the DOT, but that's not always the case. If the tank car volumetric capacity is not the right size also, you could lose the advantage of shipping at 286,000 pounds of gross railroad limit. On the other hand, too large of a tank car would mean it's heavier and could not load to the volumetric capacity. It's important and a requirement for both tank car owners and shippers who specify tank cars to be trained in hazardous material regulations. Today, regulators are asking shippers to identify who within their organization are hazmat employees in charge of tank car specification and interior linings or coating qualification plans. There are both federal and industry requirements for the inspection and testing of tank cars. An example would be the stubsill inspection and the AAR Field Manual Rule 88B are typical examples of industry requirements by the AAR. That's the Association of American Railroads. Tank car requalification requirements is a federally mandated and must be done on a 10-year or sooner cycle. Both the AAR and FRA inspections are based on a fit for service that require the tank car owner to determine the method of inspection and testing along with the analytics needed to determine the next inspection interval. Hopper cars and gondolas typically don't ship hazardous commodities and do not have the same amount of oversight that the tank cars and hazardous material services have. There are no requalification requirements for these types of freight cars. When a tank car is scheduled for requalification, there's several areas that are inspected and tested. First and foremost, there's a visual inspection. That's an internal inspection of the tank shell and heads for abrasion, corrosion, cracks, dents, distortion, defects in welds, and any other condition that makes the tank car unsafe for transportation. There's an inspection of the service equipment, including gaskets, an inspection of missing or loose bolts and nuts, an inspection of all closures on the tank car for conditions that may make the tank car unsafe for transportation, including an inspection of the protective housing for proper condition, An inspection of the required markings on the side of the car are also required. Structural inspection. All transverse fillet welds greater than 1/4 inch and within 4 feet of the bottom longitudinal center line, except body bolster pad attachment welds, are inspected. The termination of longitudinal fillet welds greater than 1/4 inch and 4 feet off the bottom of the longitudinal center line, and tank car shell butt welds within 2 feet of the bottom longitudinal center line. Then there's the tank car thickness inspection. The tank car owner must ensure that each tank car facility measures the thickness of the tank car shell, the heads, sumps, protective housing, and nozzles on each tank car. Minimum tank shell thickness requirements are in the Code of Federal Regulations and identify when repairs are required to meet the inspection intervals. The safety system inspection, the rail car couplers, thermal protection systems, tank head shields, bottom and top nozzle and fitting protection systems are all inspected to ensure there are no indications of defect that may reduce reliability before the next inspection and test interval. Service equipment inspection. Each tank car owner must ensure the qualification of tank car service equipment at least once every 10 years. Tank car owners must analyze the service equipment inspection and test results for any given lading, and based on the analysis, adjust the inspection and test frequency to ensure the design level of reliability and safety of the equipment is met. If the car is equipped with an interior coating or lining, the owner of that interior coating or lining applied to protect the tank car for transportation and corrosive or reactive to the tank must ensure that the inspection is adequate enough to detect defects or other conditions that may reduce the design level of reliability and safety of the tank. In many cases, the owner of the lining is the shipper, and this inspection and test interval is managed by that shipper. The owner of the interior coating or lining must establish and maintain a record of service life of the coating or lining and commodity combination. That is specific hazardous material that were loaded into the tank car and the coating or lining in place at time of loading. The owner of the interior coating or lining must use its knowledge of the service life of each coating and lining and commodity combination to establish an appropriate inspection interval for that coating and lining and commodity combination. This interval must not exceed 8 years. Lastly, there's a leakage test. The owner of the tank car must ensure that the tank car service equipment and closures installed, replaced, reinstalled on tank car are leak-free. The test may be conducted with a lading in the tank. Lastly, I'd like to also make mention that the lining coating qualification interval cannot exceed 8 years, while the other inspections cannot exceed 10 years. Back in the 1980s and early 1990s, a tank car was shipped to a tank car repair shop, cleaned and hydrostatically tested. Most general service tank cars' first hydrostatic test was 20 years after built. Most pressure tank cars received their first hydrostatic test 10 years after they were built. The test was simple. One would fill the tank car with water to shell full and then apply the prescribed pressure, 100 psi to 600 psi, depending on the tank car class and pressure. That tank would hold that pressure for 10 minutes on a non-jacketed tank car and 20 minutes for a jacketed tank car. Inspections of the tank for leaks and pressure retention was done. If it passed, the tank would be ready for continued service for another 10 years. If the tank car had interior heater coils, those too would be hydrostatically tested at 200 psi. The pressure relief valve would be disassembled, seats and seals replaced, reassembled, and bench tested to the prescribed pressure. Today, at least once every 10 years, HM201 was issued by the Research and Special Programs Administration, RIPSA, and the Federal Railroad Administration, FRA, with a final ruling that was published in the Federal Register on September 21st, 1995. HM201 was later codified in the Code of Federal Regulations under 49 Subpart F, Part 180.500. The rule addressed the safe performance of tank cars used to transport hazardous materials, focusing on the structural integrity and safety improvements. It also led to changes in the tank car qualifications, including requirements for shell thickness and maintenance to prevent damage from accidents. That's a good question. Shippers should be cognizant of the fact that the FAST Act deadlines will probably change in the very near future. Currently, the regulation allows you to move flammable liquids in DOT-111s and CPC 1232 tank cars, packing group 3 flammable liquids, up until May 31st, 2029. It's likely that that's going to change and accelerates to a deadline date of December 31st, 2027. There are two bills, one in the House, H.R. 7662, and one in the Senate, S. 3903. Both have bipartisan support, so we believe that this will probably pass in the very near future.